whenever you're working explicitly with memory, especially in programming languages like C and C++ that are more low level, and you're doing things with like malloc and freeing memory, there are a lot more error, like you're more prone to have errors. And so these are the main errors that you need to watch out for, and these are like the terms, and I've highlighted them in green, that will be tested in CS 252. So one of the main types is memory leak, and so this is when you're not freeing objects that are no longer being used. So just to review the memory structure, our memory is basically like a fat array. Like it's just, and it has a bunch of data sections. And whenever we're mallocing, we are using the heap, remember? And so if you keep mallocing more and more data, so you're just like really going ham and like hoarding up this space, remember this space here isn't infinite, and actually there's like shared libraries that are going to be in the middle, but eventually you are going to run out of room, and so this is a problem. And yeah, you should always remember to free your stuff if you're no longer using an object. And this is especially an issue for programs that are run for a long time. Like for example, like some servers are on like 24/7 and they're constantly running the code. And even if you have a small memory leak, but you're constantly like growing this heap and taking up heap space, and so that is going to cause some issues. Sorry, I want to erase this. Okay. So I have a dumb example, but like say you have a while loop that goes on infinitely. Well, I'm allocating, remember like new, whenever you're allocating more memory in a heap, you can either use the keyword like new or malloc. Remember that if you're using malloc, you have to use the corresponding free. If you're using new, you have to use the corresponding delete. But essentially, like what they're doing here is they're allocating a bunch of space when you don't need to, and so eventually you're gonna corrupt your memory, and that's a big no-no, so don't do that. Okay, another type of memory error is called a premature free, and it's when you're essentially trying to use memory that has already been freed. So the example here is I've allocated memory, so let's just like review the, what's it called, the malloc lab. So say I have a chunk in memory. Remember, you have your header, and I'm gonna color this purple. So yeah, let's say we allocated this, and remember your header's gonna store information such as like the type, so whether it's allocated or not allocated, or it's a fence post, and it's also going to tell you the size of the object to your left, and I think it tells you something else. I don't remember. Anywho, so, and then remember you will have like another header here, and this is if the object is in your free list. This will store like the next and previous pointers in your free list. But obviously like we don't need to keep track of our free list if it's allocated, so this will be overwritten. So in this case, like we've allocated P. This whole chunk is P, but P's really gonna point here to your header. Anyways, so we're going to write in 8. That's what's being stored, and it's going to take up the size of an integer. And it's going to start from here. So our next and previous is overwritten. But when we delete it, right, it's freeing up this, and we're keeping track of next and previous. And it's going to be added to a free list. And it's going to be pointed to the next thing. Well, now if we assign 9 to it, then it's going to rewrite this section and like basically like remove the next and previous to store a value 9. But now we don't have a pointer to the next thing in the free list, even though we're still saying, oh, it's free because we never said new. And so now you've just corrupted your free list, and now you're going to have problems later on in the line, like later on in your program if you're trying to access like some other chunk in your free list. So technically, if you do this line right here, you're not going to get an error. It's going to happen later on, which is why these types of errors are a lot more tricky to debug because they're not instantly going to show you where you screwed up. And this is why it's always good practice, if you ever like delete or free, you want to assign the pointer to be null. So p equals null. I might have to do p star, I don't remember. And this is because like if you write this before, now when you try to do this pointer, you're going to get a sig v. And so that's going to be easier to debug essentially. Okay. Double free, it really is what the name says. It's when you delete twice. It's really stupid, but yeah, don't free twice. And basically what's happening is anytime you delete or free, remember when I deleted this, I added it to the free list, and this is p, these are some other items in the free list, but if I delete it again, well, I'm adding p again, right? And remember we have our next and previous headers, we'll color that yellow, and so this will be pointing to this object. But like if it's itself, if it's saying like, oh, the next object is p, well, it's really saying like, oh, I'm pointing to myself. And so you're creating a cycle in your free list, and you're never going to be able to access like later on in your free list. Essentially, like you're just corrupting your free list, which again, you're going to have issues later on in your program. Yeah, okay, so we have two more types. We have wild freeze, which is essentially when you're trying to free memory without headers. And remember, normally when you do like malloc or new, it's creating data and it's creating like a chunk of memory in the heap, and it's going to automatically create that header that stores information about it, like whether or not it's allocated, and the size of the block and the size of the block to the left. But like say for example I have a pointer and it's pointing to just a regular integer, which remember, like say this is an integer in your function, this is in the stack of your data, not the heap. So different section of your data, different section of your memory, excuse me. And if I delete this, it's going to cause issues because you don't have that header, right? And so it's going to corrupt because you don't have like the next and previous to like basically keep track of your free list. And so either it will like just fail right here, or it's possible that it will work, but again, you're corrupting your free list, so it could also affect later on down the line. And I have another example here, the char p, this actually is allocating in the heap, right, because I'm using the new keyword. But if I move the pointer, so now I'm pointing to like, see like normally if we have a chunk of memory and this block is the header, right, I'm going to point to the front of the header. But if I'm adding 10 to it, it's going to point like later on down the object, and it's not pointing to the object. And so as you can imagine, this is going to cause issues and you guessed it, corrupt the free list. Okay. Our last one is memory smashing, and that's just when you're using more memory than you have allocated. So say I have like a string, and I've allocated space for 8 characters. Again, we have our header, and then I have like the space I allocated for the string. Well, if I allocate something that is longer, I try to put something that is longer than the 8 bytes. For example, hello world, well, I'm going to be writing past the space I've allocated, and if there are more chunks of memory next to it, see how it's corrupting the nearby neighbors. He's an evil neighbor. So yeah, that's going to be causing issues later on down the line if you try to malloc or free again. And just some dumb ways to remember wild freeze, I like to think about like there's that phrase like, oh, if you lose your head, that means like you've gone crazy and you're wild. So like headers, you've lost your head and you've gone wild. Yeah, it's stupid. And then these names, premature and double free, they're pretty obvious what they mean. Memory leaks, I like to think of that like hoarder show, like that reality TV show where you like have too much stuff, like you're heaping all your crap like in your garage, and yeah, you're just taking up too much space and your house is going to overflow. So that's how I like to remember memory leaks. So hopefully this is helpful. I'm not sure if these are like actual like legit terms for these types of corruptions, but this is just, or like these types of errors, but this is just what Gustavo uses. So that is what he will be testing on.